Do you ever wonder how a process can invoke another program, or how to invoke another program? The answer is the simple, that is the exec system call. Basically, the exec system call replaces the current process image with another executable file. For example, suppose a P1 is executing and the process P1 make a exec system call with the parameter P2, that is P2 is executable file, and after making the exec system call, the contents of a P1 are erased and it starts a new process, that is P2, and it continues the execution of the P2. So the so the main idea is basically it replaces the current process image with another. So the contents before the exec are no longer available after the system call. Here we can see that the contents of the P1 are no longer available in the P2. The contents could be, or the contents are basically, they are contents means the basically it is a context of process that is replaced by the exec system call. So old process contexts are no longer accessible in the new process, that is in a new user process address space. So it basically replaces the old process text data stack, and in the system level context it basically change the program counter and the stack pointer. So there is so much difference in the user address space of old process and the new process. Basically it's changed the whole data with the help of the exec system call. So but here is main thing to remember, that is the PID and GID remain same, that is the process ID and the group ID of the process remain same. Suppose P1 PID is 1922, then the P2's PID will also 1922. It does not change any PID and the GID of the process. So this is the basic overview of the exec system call. So before discussing the syntax of the exec system call, I would like to tell that there are so many variations of the exec system call, that is which are execl, execlp, execle, execv, execvp, execvpe. But all of this ultimately calls the execve, that is this is the main system call, and all this variation of exec calls the execve system calls. So now we are going to discuss the execve system call. So the syntax of the execve system call is basically it accepts three parameters. First one is a name of the name, argv, and envp. So name is the exe file that is being invoked, the name of the exe file that is we are going to invoke, and argv is, it is a pointer to array of character pointers that provides argument list to program. Suppose if we want to specify some parameters to a program, so we can provide through the argv. And envp is the environment for new process. So as we know that every process has an environment. So if we want to provide some specific environment to a process, so we can provide it, or else we can use environment variable, that is which is a globally access, globally available. So we can pass the environment variable, or else we can provide such a very different environment to a process using envp pointer. So that was syntax. So general system call syntax is execve, which accepts path, argv, and envp. Both these three are const character pointers, and the argv and envp are array of in short term they are array of strings. So let's discuss the working of the exec system call. First of all, it gets the inode of the executable file using a nema algorithm. After that, it checks that the type of the file, whether it is a executable file or whether it is a directory or regular file, and also check the user has permission to execute this executable file. After that, it checks the headers of the exe file and checks whether it is a load module or not, and it start copy parameters from user address space to a system, because as I said earlier that the contents before the exec are no longer available after the system call, that is exec system call. So we provide the argv and envp in the old process. So if you want to make accessible in the new user address space, so basically we have to make accessible into new user address space. So basically system copies the base addresses of the arrays, base address of pointers of argv and envp into system, and then later it copies to a new process user address space. This is a different task which is performed by the kernel, that is operating system. After copying the parameters from the user address space to a system, it continues to detaches the region of word process using algorithm detach range. And after removing the user level context, if suppose error occurred, then the process leads to the termination of program. Whether error could be no space in the kernel region table, process size is exceeding the limit of the hardware resources. So these are the types of error leads to the termination of the program. And after detaching the old process contents, it allocates region for every section specified in the exe file using algorithm alloc range, attach range, load range. Basically it starts allocating the regions for executable file, that is for text, data and stack. Data region is basically divided into two parts, that is bases and initialized data. It allocates the region for initialized data to the size that I have specified, and it just only attach the region for bases and use bases start in starting, and then it grows the region using grow range algorithm. The kernel now it clears the single handler bits in the area to 0, because there is no point to handle the signals that has specified for old process, because now the process is a new. So it clears the single handler bits in the area to 0, and the ignoring signal are always remains ignored, and at last it allocates region for stack. Then it copies the parameter from system to new process stack, which has it copies the parameters from system to new process stack. Then initialize the special set UID programs. It basically sets the who is the real user ID, real user ID is effective user ID. That is a different procedure. And then last it initializes the system level register, that is program counter to the starting address of the program, which is specified in the primary header in the executable file, and the stack pointer to the direction of growth of the stack. And at last it releases the inode of the executable file using the IPUT algorithm. So this is a working. This is a basically overview of how exec system call works. So I would like to explain exec system call with some simple program. So here is a simple program that is printing argument which is passed to a program. Basically this program prints the command line parameters which has passed to a program, and this is the main program you can see. So let's execute and then I will explain this program. First of all, gcc 20. This is the output of the program. Now let's see what let's see. This is a main program, that is execve. In this file we have invoked the execve system call. Basically this is a separate so we can consider this is a process P1 and that this is a program P1 and this is a program P2. In P1 we invoked another program, that is a PA, and basically this program prints the argument list which is passed to a program, So the syntax we have described it as, the first is a name of the executable file, second one is argv, that is commands for the process, that is command for program, and environment variable. This is the commands that I have specified. You can see in the output. You can see in this output, that is how are you. And instead of making a different environment, I used the existing environment. So I basically used environment this, which is a global variable, and we can access also. Basically I not created any different environment. I just passed the existing environment to the program, and we can see that basically this process create a child process, that is for create child process, and for forks invoke the exec system call, that is forks invokes the new program, that is PA. So we can see that the child process started. It prints this printf statement, but it not prints this statement because I told you that the exec system call replaced the process image with another. So at this point it replaced the process image, old process image with the PA. So this is not gonna execute further, so this is not gonna print. So this is the overview of the exec system call.